Okay, today we're going to discuss friction. Friction is a force that opposes the direction of motion. Okay. So if you were riding a bicycle, okay, that's my rendition of a bike, and you were going towards the right, that was your motion, okay? Friction would occur where the two surfaces meet. So there's two surfaces in contact where friction occurs, okay? And friction would be fighting or opposing the direction of motion wherever there is contact between the two objects, okay? So there has to be two surfaces in contact for friction to occur, okay? Now friction's a unique thing because we all tend to think of friction as a negative thing, okay? Because friction makes many tasks more difficult, makes things harder to do. All right, so like for instance, when you try to move your dresser across the floor, if you have a carpeted floor, it's much more difficult than sliding across a bare wood floor because the carpet has a rougher surface, okay? But a lot of the things we do, or almost anything active that we do, requires friction, okay? Most things would be impossible without friction. Most things we do would be impossible without it. Without. That's W/O means without. Okay? Now, think about that. If there's no friction, you can't grab anything. All right, so your hand would slip off everything you grab. So if you tried to take a drink of water or juice or something, the glass would slip right out of your hand and fall on the floor. If you tried to get out of your bed and there was no friction, it'd be like stepping out of your bed onto a sheet of super, super slippery ice, and you'd fall all over the place. You wouldn't be able to grab a doorknob to twist the door open. You wouldn't be able to catch a football or a baseball or anything like that. Okay? So everything from walking to opening a door to drinking a glass of water to eating all requires friction for things to stick together almost. Okay? All right, now, when friction's occurring, heat is always produced. Produced by friction. Okay? Some other factors that affect friction, okay, are the types of surfaces. The type of surface something is on will affect friction. For instance, if something is smooth, a smooth surface will result in less friction, and a rough surface result in more friction. So, for instance, a smooth surface like ice is very slippery. There's not a lot of friction there, which is what makes it slippery. If you're walking on sandpaper or trying to skate across sandpaper, you'd have a much more difficult time because it's very rough and it produces way too much friction. Okay? Also affecting friction, we have the mass or weight of the objects in contact. Okay? Remember, mass is measured in kilograms, weight in newtons. Okay? So friction will depend on the total force pressing the two surfaces together. Okay? So the more mass, the more weight something has, the more force it is going to push on the surface. So if you have somebody that's very light on a bicycle, they may not produce as much friction as somebody who's very heavy on a bicycle. Okay? Or an empty box, an empty dresser. If you want to push your dresser across the floor and you take all the clothes out of it, it's a lot easier to push than when all the clothes are in it because there's less mass inside of it, and therefore it's not pressing as hard and creating as much friction. So friction also depends on the total force pressing the two surfaces together. Okay? So what is sliding friction? Well, the word kind of tells you almost exactly what it is. All right? Sliding friction occurs when one surface slides across the surface of another object. Now, this is key here. This is something to remember. So surface area has no effect on sliding friction. Surface area, no effect on sliding friction. Okay, so what does that mean? Look, if you have a box, okay, and its surface is all this area right here touching the floor, all right? So this whole area from here to here is touching the floor. And that box is 500 kilograms. It produces just as much friction between the surface as it would as if it were up on a set of legs, like let's say like a desk or a chair. Okay, so if we had that same 500-pound box, or 500-kilogram box, excuse me, sitting on two legs, so the only surface area, the only surface touching are the two legs, okay, the same exact amount of friction is produced. So friction sliding friction is not affected by surface area. And the reason we point that out is because in a future video, we're going to talk about fluid friction, where you have surface area having an effect on it. But for sliding friction, it does not affect the friction, okay? Now, something called starting friction is important because in order to overcome Newton's first law of inertia, you need more force, okay? So more force is required to start something moving than to keep it moving, okay? So the reason that is because of Newton's first law of motion. When we said that object wants to, if it's staying still, it wants to remain staying still. So what you have to do is you have to apply more force just to get it to start moving. And you might have realized this if you've ever moved your dresser around. Once you get it moving, if you don't let up and you keep applying the same amount of force, it starts to get faster and faster. But while you're doing that, you start creating more friction, and that creates more heat. Okay, so that's all we're going to talk about for today. All right, we talked about the factors affecting friction, what friction is, sliding friction, and what starting friction is. So if you have any questions, please make sure you come ask one of us as you work on your task list, and we'll be roaming the room to help you out with anything and any questions you have. Okay, we'll see you tomorrow. Take care now.